Hello everyone, once again I'm Erisa Wante, your online mathematics teacher. I'm back with the trigonometry lesson 2. Yesterday we introduced trigonometry in lesson 1 and we talked about trigonometry, uses of trigonometry, we talked about the general angle, we talked about ratios, sine, cosine, tangent and their reciprocals. Okay, we went ahead and talked about measurement of angles. We measure in degrees or radians, and we saw the conversion from degree to radians and the other way around. Okay, we concluded by talking about yesterday. We concluded by talking about something. Let me check here what we talked about yesterday. We talked about the general angle, okay, how angles are measured. Okay, angles are measured either in the anti-clockwise sense or the clockwise sense, starting from the positive side of the x-axis. That was discussed yesterday. Today we want to continue with our lesson in trigonometry, and we want to talk about basically today we are going to discuss quadrants. Okay, we want to see how is the knowledge of the behavior of ratios in the different quadrants helps us in solving trigonometric solution problems. Okay, let's take a look. As always, I want to produce a lesson but with a small file size. So what I do, I take out my video. That way you will access a file which is a bit light, that will not rip your pockets in terms of data. Okay, data size, you use MBs. Okay, here I use Wi-Fi, it is unlimited and I can do anything with it, but I sympathize somebody who is pulling out money in the pocket every day to access this information on YouTube. So let me take out my video and we go ahead and talk about quadrants. You have all looked at the Cartesian coordinate system. We have the x-axis and the y-axis. Those two axes divide any plane of paper into 4 equal parts, and those parts are called quadrants. So we write the coordinate axes divide a circle. Let's see, okay, we can say plane of paper, a circle of any radius into 4 parts. So as the positive angles are measured in the anti-clockwise direction, the quadrants are numbered the same way. So you remember yesterday we said that when measuring angles, you start from the positive side of the x-axis. If you move in an anti-clockwise direction, then you are measuring positive angles. And if you move in the clockwise direction, then those are going to be negative angles. So we are saying that if you have the coordinate system here, okay, you can draw a circle around it if you want, but I not draw a circle around it. So this is the x-axis and this is the y-axis. Okay, now they have divided this plane into 4 equal parts, and these parts are called the quadrants. So the first one is here. Okay, we start from the positive side of the x-axis and move in the anti-clockwise direction as we number these quadrants. So this is the first quadrant. Okay, then this is the second quadrant. This is the third quadrant. and this is the fourth, okay, quadrant. So the quadrants are numbered in an anti-clockwise direction, starting from the positive side of the x-axis, okay. The first portion, or that quarter, the first quarter is what we call the first quadrant, second quadrant, third quadrant, okay. When numbering quadrants, remember, it is an important point here, go in an anti-clockwise direction. So what happens in the first quadrant, okay? The first quadrant consists of angles between, I'll abbreviate that word, between 0 degrees and 90 degrees, okay. Angles between 0 degrees and 90 degrees, or from 0 degrees up to 90 degrees, okay, are called, they are in the first quadrant, and these are called acute angles. Acute angles, okay. Yeah, from the word acute, just add a and you get the name of the angles in the first quadrant. They are called acute angles, okay. So what about the angles in the second quadrant? The second quadrant consists of angles between 90 degrees and 180 degrees, okay. So these are called obtuse, okay. They're called obtuse angles. So angles between 90 degrees and 180 degrees are called obtuse angles, and those angles are gonna be in the second quadrant, okay. So what about in the third quadrant and the fourth quadrant? Do we have a name for angles in the third quadrant? What about in the fourth quadrant? Okay, so the angles in the third quadrant and the fourth quadrant have a general name. So we write angles in the third and fourth quadrant are generally called, reflex angles, okay. Reflex angles. So reflex angles are gonna be in the third and in the fourth quadrant, okay. The angles in the third quadrant and the fourth quadrant, I'm repeating it, are generally called reflex angles. So if someone talks about a reflex angle, you need to specify or to give you more information to determine in which quadrant it is, okay. So it is either in the third or it is in the fourth quadrant. Now, after just talking about this information and discovering the name of the different angles in each quadrant, we want to see the behavior of the trigonometric ratios in each of the four quadrants. So by behavior of the ratios in each of the four quadrants, we want to see, okay, the ratios of sine, the ratios of cosine, the ratios of tangent. Are they positive? Are they negative? Okay. So to do this, we are going to use the coordinate system you have been looking at since you are in P2, okay. In this system, you know how you plot negatives and positives. So that's called the Cartesian plane. So let's consider, okay, consider an angle theta 1, okay, between the x-axis x-axis, and a vector OS in the first quadrant. Okay, we have the coordinate system here. Okay, this is the x-axis, and this is the y-axis, positive axis, okay, y-axis. Now, we want to draw a line from the origin, okay, a line of some length r, and we call this point S, okay. When you are looking at the coordinate system in the first quadrant, okay, on this side you are going to plot positive x's, maybe 1, 2, 3, 4. Then this side you plot the y's, okay, 1, 2, 3. They are positive values, okay. So I want to draw a line from here to meet the x-axis at 90 degrees, okay, and the distance from this point here, okay, let me call this point the origin, okay, the distance from the origin up to somewhere here, okay, maybe this is n, that distance is x1, okay, and then this is a y1. So this line I have drawn, it is making an angle theta, okay, the angle made here is theta 1, okay, with the x-axis and that line OS. So S has coordinates x1, y1, okay. But from the coordinate system, okay, we know that x1 and y1 are positive values, okay. On this side of the x-axis, the right side of the x-axis, we only have positive values of x, okay, and then above the x-axis we have positive values of y. So S as a point has the coordinates x1 and y1, okay, where x1 is the length from O to N and y1 is the length from N to S. So if we are to read sine of this angle, sine, okay, using the right angle triangle we have created, before that, let's say that from O to S, that length equals to R is always going to be positive, okay, is always positive. Okay, I have put this image on the next page so we can see clearly without referring back to the previous page. Now, what do we know here? We know that in the first quadrant, the coordinates of point S are x1, y1, and they are both positive. Okay, so what is the sign? Okay, what is the sign? Oh no, this is bad. What is the sign of theta 1? We say the sign is opposite, if you remember what we discussed yesterday, out of the hypotenuse. Okay. So the side which is facing the angle is the opposite side. That's the opposite. Okay. And the hypotenuse never changes, the longest side of right angle triangle. So in this case, we have y1 out of r. But we know that y1 is positive and r is positive. So this ratio is a positive ratio. When you divide the value, any value you have for y1 by r, you are going to get a positive ratio for sine theta 1. Okay, what about the cosine? What is the cosine of theta 1? This is the adjacent out of the hypotenuse. And the adjacent side is this other side down here. This is the adjacent side. Okay, the side that meets the opposite at 90 degrees is the adjacent side. So the adjacent side is x1, okay, x1 divided by r. But since x1 is positive, you know, from the coordinate system, the value from the origin going to the right of the x-axis, any value of x is going to be positive. So you're getting x1, which is a positive, and dividing by r, which is a positive. So this is going to be a positive ratio. Okay, what about the tangent of that angle theta 1? Tangent is the opposite divided by adjacent. The opposite is y1 divided by x1. Both x1 and y1 are positive, so this is also a positive ratio. Okay, so any angle between 0 and 90 degrees will always have positive ratios. Okay, compute the sine of 20 degrees, it will give you a positive answer. The cosine of 20 degrees, you'll get a positive value. The tangent of 20 degrees, okay, will give you a positive value because this is the first quadrant. And in the first quadrant, we are discovering that all ratios are positive, okay? So this is something very important as a student trying to learn something in mathematics. These are some of the facts that should be always on your fingertips, okay? These are things which are going to be repeated over and over, so you learn it there and then, okay? We are talking about the sine of 20, okay? Here we say 20, but I don't want to say that. Sine of 20 degrees is gonna be 0 point. If I write this to 4 places of decimal, 0.3420. These are 4 decimal places, okay? What about the cosine? If I got the cosine of 20 degrees, cosine of 20 degrees, let me clear this first. Okay, cosine of 20 degrees is 0.9396, okay, 97. Still 4 decimal places because I'm not writing everything. That's the degree of accuracy I'm stating for you. What about the tangent? Okay, tangent of 20 degrees is gonna be 0.36, okay, 40 if you write this to 4 decimal places. So they are all positive ratios because 20 is an angle in the first quadrant where all ratios are positive. Okay, let's go to the second quadrant. So you consider an angle theta 2 in the second quadrant. So we are saying this 90 degrees less theta 2 less or equal to 180 degrees. We are looking at the second quadrant. Okay, still we make use of the coordinate system. Okay, I will draw, this is my origin. I draw a line from here, okay, and that line will have length r. This point is S. Okay, so if I try to create a right angled triangle between the line I have drawn on the x-axis, then this is the angle I'm talking about. From here up to here is the angle I'm talking about as a theta 2. But for some reason, you are going to discover why we use this other angle to determine the ratios, okay, of the angles in the second quadrant. Yes, the angle we want is from the positive x-axis here, okay, all the way to the line OS, okay. But when we are getting the ratios of that of those angles, we use the angle between the x-axis, okay, and the vector OS, wherever it will be, okay. So let's say this is going to be from here. You all know that the value of x from 0 up this point n, okay, that value of x is going to be negative. So I'll call this minus x2 because it is on the left side of the x-axis. Any x value on any value on the x-axis left side is going to be a negative value. But the y values here, it is above between n and s from here up to here. That y value, which I'm calling y2, is a positive value. Okay, in real, if you can go ahead and plot, you know, you are going to discover that if you try to plot a coordinate in the second quadrant, the x value is going to be negative and the y value will be a positive. So this minus x2 and then y2. Okay, information before I go ahead and okay, I will say that r is always positive. Okay, r is the length of the vector from O to S. That length, okay, of that vector, which I'm calling r, is always going to be positive, irrespective of the quadrant. It will always be a positive. Okay, so you can go ahead and read sine theta 2, cosine theta 2, tangent theta 2. Remember, I'm telling you that we use this angle between the line OS and the x-axis. The angle we want, yes, is this one from here up this line, but we are going to use the angle between the vector OS and the x-axis. Okay, so this side, this case is negative x-axis. Okay, let me copy this image and take it to the next page so we can make use of it. So I need to highlight this. Okay, I use a very advanced app. Okay, and I pay money for this app, but I'm giving you free education, so it is something you should really value so much. Okay, so let me go ahead and do what? Copy this image, move to the next page, and paste it here. Okay, so we have our image on the next page. What we can do now is to go ahead and move it to a position of interest. Okay, this is some kind of advanced technology I'm using to deliver this lesson, I have to tell you frankly, and it is very expensive for sure. This is very expensive, but the knowledge, surprisingly, is free. You just go to YouTube and access it. All right, so what will be the sine of theta 2? Okay, the side which is facing the angle here, okay, it is y2 divided by r. Okay, and y2 is a positive value. This is a positive. R is always positive. The cosine of theta 2 is a minus x2 divided by r, adjacent over hypotenuse. Okay, and negative divided by positive, you get a negative. Okay, and then the tangent of theta 2, tangent is opposite. Okay, sometimes I'll be reminding you, opposite divided by the adjacent. So the opposite is y2, which is a positive value, and we are dividing by a negative value, x2. So this is going to be a negative ratio. Okay, now any angle between 90 degrees and 180 degrees will have sign in positive, but the rest of the ratios will be negative. For example, you just pick any angle of your choice. Okay, if I look at the sine of let me say 128 degrees, I picked this randomly. Okay, 128 is between 90 degrees and 180 degrees. So if I go ahead and compute the sine of 128 is gonna be 0.7880. This is to 4 decimal places. Let me hope I'm computing in degrees. Yes, my calculator is set to work in degrees. Sometimes if you set to work in radian, it's not to get the values I'm talking about. So check the mode of operation. Okay, the cosine of 120 degrees, okay, is going to be negative. Okay, so because 128 is in the second quadrant, so let's go ahead and compute it. What's the cosine of 128 degrees? It is a minus 0.6157 to 4 decimal places. Okay, pick any angle of your choice and work with it. You know, as a student, you must be practical when you are learning. Okay, if a teacher is doing something, okay, I'm working with 128, work with a different angle and see if you are going to get the same, you're going to get same results I'm talking about. So this 128 degrees. Then the tangent of 128 degrees is going to be negative before I even compute it. I know the reason is in the second quadrant where only sine is positive. Okay, so tangent of 128 degrees is gonna be, okay, a minus 1.279. Okay, maybe let me say minus 2.8 because it is 99. So if I work with 4 decimal places, this is going to be 804 decimal places. Okay, angles in the second quadrant only sine is positive. Why are we talking about this? The relevance of this knowledge will appear when we start solving trigonometric equations. So we have that information. Third quadrant. Okay, but before I go to the third quadrant, let's highlight this information. I have just talked about it. You'll forget it. So let me write it down. The ratios. Okay, here is the point. The ratios of angles in the second, third, and the fourth quadrants are found by taking the angle between OS and the positive or negative x-axis. You have seen here that when I was working with an angle theta 2, okay, let's say this angle is 135 degrees. Okay, if I want to get the ratios of 135 degrees, then I have to consider, I draw that vector OS, okay, and then I look at the angle between OS and the x-axis, positive or negative. In this case, it is negative x-axis. So here, the angle I'm left with is about 135 degrees. We want to make 180 degrees, so that's going to be 45 degrees. Okay, so the sine of 135 degrees will be found by just considering the sine of 45 degrees, and we are going to discuss that point more. Okay, so that's why when I was working with the second quadrant here, if you have been so keen, I talked about the angle as theta 2, okay, but when I was getting the ratios, I used this other angle, okay, yeah, to give me the ratios of this angle theta 2. So that's the point which is very, very important. Take it seriously. Let's consider an angle in the third quadrant, an angle theta 3 in the third quadrant. So that's gonna be between 180 degrees less theta 3 less or equal to 70 degrees. Okay, all right, so here is the coordinate system. I prefer using black because it glows on a white background. Oh my god, repeating the same thing. Okay, let me pick a black color here. All right, so I have this and I have this. That's the coordinate system. Okay, so I want to measure an angle theta 3, okay, and it ends somewhere here, theta 3. All right, so what I do, this is going to be the S point, okay, so I try to create a right angled triangle, and I make use of this gap, the angle here, okay, to determine the ratios of theta 3. Remember, theta 3 starts from the positive side of the x-axis and ends on that vector OS. Okay, so this is negative x3 and this is a negative y3. This is a point N. Okay, you have your y-axis and then you have the x-axis. So you read the sign Okay, this 90 degrees, because when you're getting ratios, we work with right angled triangles. Okay, so what's the sine of theta 3? Sine of theta 3 is opposite, which is a minus y3. Remember, this is always r. R from O to S, that length is r and is always positive. Okay, so opposite over hypotenuse, this is a negative ratio. Okay, the cosine of theta 3 is adjacent. The adjacent here is minus x3 over r, and this is also a negative because we are dividing a negative by a positive. What about the tangent of theta 3? Tangent is opposite, this side divided by this side here. So the opposite is minus y3 divided by minus x3. Okay, when dividing a negative by negative, you end up with a positive answer. Okay, so any angle in the third quadrant will have tangent positive and the other two ratios negative. So pick any angle of your choice. Remember, this is between 180 degrees and 270 degrees. So if I can pick any angle of my choice, maybe 200 degrees, sine of 200 degrees, without computing, I can tell that this answer is going to be negative. Okay, you can try to compute the cosine of 200 degrees. It is going to be a negative answer, and the tangent of 200 degrees will be a positive answer. Okay, this is going to be a positive. So this is what we really need about quadrants and the behavior of ratios. We have seen that in the first quadrant, all ratios were positive. In the second quadrant, it is sine that is positive. And in the third quadrant, we are discovering it is only tangent which is positive. Okay, let's look at the fourth quadrant. Let's consider an angle theta 4 in the fourth quadrant, an angle between 270 and 360 degrees. So this is the x-axis and this is the y-axis. Okay, you draw a vector from the origin, and then you were interested in this angle, which I'm calling theta 4. But we are saying that when determining ratios of angles from the second to the fourth quadrant, we use the angle between the x-axis and the line OS. This is O and this is S, having x4 and then y4. Okay, so if you start from the origin, let's create a right angle triangle here. So this is 90 degrees. Okay, from here, from the origin to a point N, that length is x4, but it is now positive if you were familiar with the coordinate system. And from N to S is a minus y4. Okay, it is a negative value. Okay, so what is sine? What is the sine of theta 4? Okay, what is opposite that angle? It's a minus y4 over r. Okay, and this is a negative ratio. What about the cosine of theta 4? Is x4 over r, and this is a positive because the x value there is a positive. When you're plotting coordinates in the fourth quadrant, x is positive, y is negative. Okay, then the tangent of theta 4 is a minus. It is going to be the opposite, y4 divided by x4. So this is negative. Now, we are discovering that in the fourth quadrant, only cosine is positive. The rest are negatives. So, pick an angle of your choice between 270 and 360 degrees and try to compute the ratios. You discover that cosine is going to be positive, the other ratios will be negative. Okay, so let's write something here. Okay, we can summarize these results by writing which ratios are positive in each quadrant. Okay, we have seen that. Let me draw a small circle here and then divide it into quadrants. We have seen that the ratios of angles in the first quadrant, or the ratios of all obtuse angles, are positives. Okay, all ratios are positives. Sine is positive, cosine is positive, okay, tangent is positive. But for obtuse angles, it is only sine, okay, and when you go to the third quadrant, you have tangent positive, and then it is cosine in the fourth quadrant. So you can try to remember this. Okay, let me write for you this information. You might need it to memorize. To memorize which ratio is positive in each quadrant, we can use a mnemonic for the first letters of the positive ratio in each quadrant. You know, a mnemonic is a word that you come up with to help you remember something. I remember when I was still in high school and we are learning the causes of accidents in Uganda. So we would come up with a single word that helps us remember the point. So this is what we call a mnemonic. And one of them is, so let's say that one of such is, okay, it is a hard time right now. I know the pandemic has ruined people's lives. Okay, we are no longer, living the life we used to enjoy. You cannot go out in public without a mask right now. Okay, here in the United States, life is back to normal, but I heard that Uganda is now a hot spot. So let's use this word to remember. Since we have learned this during the time of the pandemic, we use all of us should take care. Okay, all should take care. All, that's first quadrant, all are positive. Should, you are picking the first letter sine, okay? It is sine which is positive, okay? Take, that's third quadrant, is tan which is positive, and care, that's cosine, that is positive, okay? So that is it about the behavior of ratios in each of the quadrants. Okay, so I'm here at Oklahoma State University. I wanted to show you around. This is the place where I'm filming from. It is just the housing for graduate students, but it's so big. And the time now is 9 p.m. The sun has just set. In summer, we have longer days than nights, okay? The sun rises at about 6:30 in the morning and sets at 9 p.m. So we have longer days. That's why I'm taking off some time to give you this kind of education, because I'm always busy, okay, throughout. But at this time of the night, which is actually daytime, that's when I get time and give you this lesson. So we have been talking about the sines of sine, cosine, and the tangent. But what about their reciprocals? So the sine is of cosec. Cosec is the reciprocal of sine. Okay. Sec theta. Okay. Cot theta. And determined. Okay. Are the same as their reciprocals. The same as their reciprocals. Okay, so if you want, if sine is positive in the second quadrant, even cosec is going to be positive in the second quadrant. Okay, if tangent is negative in the second and the fourth quadrant, even cosec is going to be the same. Okay, so there is a point worth noting before we start discussing more about this. So one point to note is that angles for which OS is equally inclined to the positive or negative x-axis have trigonometric ratios of the same magnitude. So one point to note, I repeat this, is that angles for which OS is equally inclined to the positive or negative x-axis have trigonometric ratios of the same magnitude. Their sign being determined by the quadrant the angle lies in. Okay, one point to note. Let me emphasize this point with this as the last example in today's discussion. So, emphasizing here is one point to note is that angles for which OS is equally inclined to the positive or negative x-axis have trigonometric ratios of the same magnitude. Okay, same magnitude. What does this mean? This is the point worth noting. Okay, let's consider the angles 10 degrees, 170 degrees, 190 degrees, and 350 degrees. Okay, so 10 is in the first quadrant. Just here, the angle is 10 degrees. Okay, then when you go to 170, that's the second quadrant. So 170, you move from here up to some point, and the angle will be 170 degrees, second quadrant. But the inclination property, okay, demands that you have to know this angle. Okay, this line OS, the inclination here is 10 degrees because we're left with 10 to make 180 degrees. What about the next angle? It is 190 degrees. 190 is going to be here. Move from here. This is O. This is S. Okay. The angle. Let me take off this. Oh my God, I used something so big. Okay. So this angle is 190 degrees. But the inclination between the x-axis, okay, here is 10 degrees. Then the last angle is 350 degrees. Okay, 350, you move all the way, almost reaching the x-axis, but you are left with 10 degrees to reach the x-axis. So this is 350 degrees. So the point it means that the sine of 170 degrees is the same as the sine of 10 degrees because of the inclination. It's the same as the sine of 10 degrees because 170 is inclined to the x-axis at an angle of 10 degrees. The same happens to the sine of 190 degrees. This will also be the same as the sine of 10 degrees because when you look at 190, this angle here, okay, it is inclined the x-axis at 10 degrees, but we have to make use of the knowledge of quadrants. In the third quadrant, sine is negative. Okay, so this will carry negative. The sine of 350 degrees, 350 degrees will also be the same as the sine of 10 degrees in magnitude, but because 350 is in a quadrant where sine is negative, we put a negative here. Okay, so what about the cosine of 170 degrees? This is also going to be the cosine of 10 degrees. In terms of magnitude, they are the same, but it is in the second quadrant where cosine is negative. Okay, so next we talk about the sine, the tangent of 350 degrees. Now I'm secting randomly. Okay, this is the tangent of 10 degrees, the same. Okay, I will still bring it here. 350 is an angle from the x-axis, the positive angle. Okay, so that is 350 degrees, but we are looking at the inclination, the angle left to reach the x-axis. Okay, here is 10 degrees. And therefore, the ratios of 350 and ratios of 10 will be the same. Okay, if we say tangent of 350 is equal to tan of 10, that is true in terms of magnitude, but it is in a quadrant where tangent is negative. Okay, the tangent of 170 degrees. Okay, or let me discuss this one, which is 190 degrees. 190 degrees. Okay, this is the angle 190. From that is 180, you add on 10 to get 190 degrees. Okay, this is 10 degrees. This whole angle from here up to here is 190 degrees. The tangent of 190 degrees is the same as the tangent of 10 degrees. Okay, now the question is, in that quadrant, is tangent positive or negative? So in the third quadrant, tangent is positive and the two balances, but the cosine of 190 degrees, yes, it is true, this will be the cosine of 10 degrees, but this will carry a negative because in the quadrant, the third quadrant, only tangent is positive. So we shall continue to discuss more about this tomorrow. Okay, let's end this discussion today, and this has been the second lesson in trigonometry. I intend to discuss all the trigonometry for the senior 5 students and for the senior 6s who feel they want to know more about trigonometry, and also there are those people who are just enthusiastic, they just need knowledge and they keep refreshing. So this is your time to shine. Okay, see you next time.